Okay, so this video is going to be looking at how to tackle different types of SQA past paper calculations questions. So all of these are going to be related to mole calculations, either masses or solutions. So let's get started. So the first few are all multiple choice. So we have the first question: which of the following substances has the smallest gram formula mass? So to do this, you need to basically work out the gram formula mass, but some of them you're actually going to be able to eliminate from the start. Because, for example, smallest gram formula mass, CO2. CO2 automatically is bigger than CO, so it can't have the smallest mass. So we can eliminate that one. And then let's just do the other one. So you're going to need to use page 7 of your data booklet to look up the masses of each one. So for carbon, that's going to be 12 plus oxygen is 16, so that's 28. Nitrogen, well, nitrogen is 14, and there's 2 of them, so that's also 28. And then finally we've got methane, CH4. So carbon is 12, and there are 4 hydrogens, and each hydrogen is 1. So when we add that, that's 12 plus 4, which is 16. So that is our lowest one, or D. The next question: what is the gram formula mass of ammonium sulfate? Well, for ammonium sulfate, we're going to have to work out the formula and then do the gram formula mass. So ammonium and sulfate, both of those require us to look up the table on page 8 of the data booklet. Ammonium is NH4 and sulfate is SO4. Because sulfate ends in ATA, so do that. NH4, the column that it's in has 1 positive written at the top, so it's got a valency of 1. Sulfate, the column is 2 negative, so the valency is 2. So that's our symbol, our valency, SDF. So we're going to swap 2 and 1. When we divide, well, we can't simplify it, so it's the same. And so our formula is going to be NH42SO4. So that means we've got 4 oxygens, we've got 1 sulfur, we've got, so the bracket, number outside the bracket multiplies everything inside. So there's 1 nitrogen inside, multiplied by 2 gives us 2 nitrogens, and 4 hydrogens inside, multiplied by that 2 gives us 8 hydrogens. So oxygen is 16, 4 times 16 is 64. Sulfur is 32, so that's that. Nitrogen is 14, so 2 times that is 28. And hydrogen is 1, so that's just going to give us 8. When we add all of those together, I'm just going to use my calculator. We've got 64 plus 32 plus 28 plus 8 equals 132. Check, is that one of the answers? It is. So that's our answer. Right, the next questions are going to be more mole calculations based ones. So we've been told here 0.25 moles, so that is a number of moles, so that's an N. I'll label that in the question so I don't forget. And potassium hydroxide was dissolved in water and the solution made up to 500 centimeters cubed. Well, 500 centimeters cubed, that is a volume. So I've got an N and I've got a V, and the question is asking for concentration. So if I remember, I know that N equals CV, so N equals C times V, so concentration is going to be N divided by volume. My number of moles equals 0.25. My volume, well, that volume's in centimeters cubed. It needs to be in litres. So I divide by 1,000. So 500 divided by 1,000 is 0.5. And when I put that into my calculator, I should get 0.5, which is answer C there. Now this next one, which of the following solutions contains the least number of moles of solute? So it's number of moles, and so it means I'm going to be using N equals CV. So for each one of these, I'm going to have to calculate the number of moles. This volume is in centimetres cubed, so when I'm working out my number of moles, I need to divide that by 1,000 and then multiply that by my concentration. So that's going to be 0.1 multiplied by 0.4. The second one is going to be 0.2 multiplied by 0.3. The next one is 0.3 multiplied by 1. And then I've got 0.4 multiplied by 0.5. So that's going to be 0.04 when I multiply it. 0.06. And that one is 0.3, and this one is 0.2. Now the question asks for the least number of moles, which is that one, so my answer is A. Now the final question is actually quite a tricky way of asking the question. It said 1 mole of sodium chloride can be used to prepare, and then we've been given volumes and concentrations. So this time, that 1 mole is Rn, and here we have got a volume, all of these are a V, and all of these are a C. So we're trying to see all of our N equals C times V and find the one that gives us N equals to 1. Okay? So again, it's going to be N equals CV. So that's 0.25, because remember, it's a volume in centimetres cubed. Divide by 1,000 to turn it into litres, multiplied by 0.4. Then the next one is 0.25 multiplied by 4. Next one is 0.2 multiplied by 0.5 and 0.2 multiplied by 1. So the bottom one is going to be 0.2. The next one is 0.1. This one is 1.0, and the top one is 0.1. So we were looking for which one is 1 mole, so it's that one. So my answer is B. Now those were the multiple choice questions. We have got some extended questions. We've got 3 of slightly longer type questions to do. So question 6 here. A student was asked to carry out an experiment to determine the concentration of a copper 2 sulfate solution. The student found that 100 centimetres cubed of, so that's a volume, solution contained 3.19 grams. So grams, that's a mass. And I've also got a formula. So the information I've got a volume equals 100 centimetres cubed, which is 0.1 litres. I know that my mass equals 3.19 grams. And I know that I've got a formula, CuSO4, so I can work out a GFM. So that's going to be 4 times 16, 1 times 32, and 1 times 63.5. And I'd be looking up all those values in the table. So that is going to be 64, 32, 63.5, and when you total those, it should be 159.5. And that is my GFM. Now, I've been asked to calculate concentration. The equation I know is concentration equals number of moles divided by volume. I have this, but I don't have that. So I need to work this out. And the information I have a mass, and I have a gram formula mass. So that allows me to calculate a number of moles, because number of moles equals M divided by GFM. So that's going to be 3.19 divided by 159.5. So I'm going to put that into my calculator. Oh, sorry. 3.19 divided by 159.5, and that equals 0.02. So I've now got n. So I can now do this calculation. So C equals n divided by V, which is 0.02, and my volume was 0.1. And when I do that division, that gives me 0.2 moles per litre. That number says that this question was worth 1 mark. That question would not be worth 1 mark. That question would be 2 or 3 marks. Okay. Question 7. Okay, so this one, we've got a balanced equation. We've been asked to calculate the mass of ammonium phosphate. So that's ammonium, that's phosphate. So that's ammonium phosphate is this. That would be produced from 510 grams of ammonia. Okay, so just like every question, I'm going to write out everything I know. And so I'm going to start with the mole ratio, because it's asking me to use the mass of ammonia to work out how much of this. So I have 3, and that's going to 1. So mass. I know the mass of ammonia is 510 grams, and that's what I've been asked to calculate for this one. I've got a formula and a formula, so I can calculate GFM. So my GFM, I ignore that 3, and it's just going to be NH3. So that's going to be 1 times 14 and 3 times 1. And when I add that together, that gives me 17. And then on this side, I've got 4 oxygens. I've got 1 phosphorus. That number multiplies everything inside the bracket. So inside the bracket, I've got 1 nitrogen multiplied by 3 gives me 3 nitrogens. Each nitrogen is 14. And inside the bracket, I have 4 hydrogens multiplied by that 3, it gives me 12, and each hydrogen is 1. So when I add those together, I've got 4 times 16, so sorry, 64, 31, 42, and 12. So when I add those together, 64 plus 31 plus 42 plus 12, that gives me 149 as my GFM. Okay. Now, I've got a mass and a GFM, so I can calculate my number of moles. N equals M divided by GFM. So that's going to be 510 divided by 17, and that equals 30 moles. Now I go back to my ratio. 3 moles of this goes to 1 mole of that. I have 30 moles. So here I divided by 3, so I'm going to have to divide by 3 here. That's going to be 10. So I have 10 moles, and I have a GFM of 149. So I can do mass equals number of moles multiplied by GFM, which equals 10 multiplied by 149, which is 1,490 grams, or if you divide by 1,000, 1.49 kilograms. And we've got one final question, and it's a titration question. So this titration question is really important because in a titration question you usually have a diagram, and that diagram gives you information that you need to use. Okay? So I've got a bromine solution and I've got a concentration here. So that is my concentration of bromine. I've got a flask and it's got 20 centimeters cubed, so that is a volume, and that is a volume of cleaner. Okay, so from the diagram I've been given information. Next thing I'm going to do is I'm going to read the questions. What average volume should be used in calculating the concentration of limonene. So in this table might be set out differently to how we've done it. So this time we've got reading across rather than reading down. We've got the titer, that just means your volume used. So we've got one that's 16.6, and that's the first experiment. So that's probably a rough experiment. And then we've got one at 16.1 and one at 15.9. They are in concordance. So we can use those. And it's asking for our average volume. So our average is going to be 16.9 plus, 16.1 plus 15.9, and then divide it by 2, which gives us 16.0 centimeters cubed. And that is our volume of bromine solution. So that equals our volume of Br2. The next question here we've got, given an equation. Always, before I even do anything, I'm going to write a ratio, 1, 2, 1. And we've got the equation for the reaction between limonene and bromine solution is shown. So calculate the concentration of limonene in household cleaner. So that is that's what's in the cleaner. So for this one, what I know is that volume was in the diagram here, 20 centimeters cubed, which equals 0.02 litres. For my bromine, well, at the top I had a concentration of 0.5 mole per litre, and all of this table was the bromine solution, and my average volume was 16 centimeters cubed, which equals 0.016 litres. And what I've been asked to calculate is my concentration. Okay, so I can do this in a few ways. I'm going to work out my number of moles. N equals CV. So that's going to be 0.5 multiplied by 0.016. So my calculator, 0.5 multiplied by 0.016 equals, so that says 8 times 10 to the minus 3. Now, what that means, that's a scientific notation, and if it's minus, see where the multiplication sign is? If I treat that as my decimal point, minus 3 means I jump 1, 2, 3 spaces and move the decimal place. So it's going to be 1 takes it over the 8, another 1, we'll have to put a 0 in front of it, and another 1, another 0. So that actually equals 0.008 moles. So that's going to get me my first mark. Next thing I'm going to do is use my mole ratio. So 1 was to 2. So if I have 0.008, that's going to be half of it, 0.004. And I've now got my number of moles. I've got a volume, so I can do concentration. Concentration equals N over V. So that's going to be 0.004 divided by 0.02. Which is 0.004 divided by 0.02 equals 0.2 moles per litre. So that's how we do that question. So this video has tackled a whole host of different calculations that you could be asked. You were able to see that for multiple choice questions, sometimes you actually do have to do quite a few calculations just for 1 mark. And particularly for the titration question, what you need to pay attention to is that in your diagram and in the very first part of that question, you're often given a lot of information that helps you in later steps. So hopefully this video helps you when it comes to approaching questions in your tests.